Hello everyone, welcome to your partner in education, Agile Rank Mate. Today, in this episode of AEEE training, we're going to be looking at some sample questions with their solutions from AEEE. So AEEE is a very hard exam to get materials of, so therefore we thought we'd create some videos about sample questions, and we explain here how to solve these questions. So let's start off with our first question. 4 masses of 1 kilogram each are placed at 4 corners of a square of side 2 meters placed symmetrically in the xy plane. The square is set in rotation around the z-axis with an angular velocity of omega equal to 2 radians per second. The angular momentum of the system in motion in SI units is. So how do we solve this question? So we have 4 masses of mass 1 kg, so therefore the total mass m is equal to 4 kilograms. Now the side of the square is 2 meters and it's placed in the xy plane. We need to find out the angular momentum, that is L, of this system. We're also given the angular velocity as 2 radians per second. So how do we solve this question? Well, as you can see, we have a square of side 2 meters which will be spun around the z-axis. So basically this is how the rotated plane would look like. So basically what we can gain here is that all of these masses are equidistant from the center. So therefore the distance between the center of the square and any mass can be calculated as the radius of the circular motion. Now, how do we calculate this radius? Now here we use the Pythagorean theorem. So 2 times the radius, that's the diameter, is the hypotenuse, or it is in fact the diagonal of the square. So 2 times r is the diagonal, which we calculate as under root of the sum of 2 sides, which is basically 2 square plus 2 square, which is 4 plus 4, that's under root of 8, which is equal to 2 times under root of 2. So we know that the diameter is 2 root 2, so therefore the radius is under root of 2. So now that we found out that the radius of the circular motion is under root of 2, we can proceed to solve this question. Angular momentum, or L, is represented as m times v times r, where v stands for linear velocity. Now we need to calculate this linear velocity. So how do we do that? We're given angular velocity and we're also given the radius. So linear velocity v is often referred to as r times omega, where omega is the angular velocity. So r here stands for 2. R here stands for under root of 2, and omega stands for 2 radians per second. So therefore the value of v is 2 root 2 meters per second. Now that we know the velocity, the mass, and the radius of the circular motion, we can calculate the angular momentum. So L here turns out to be 4 times 2 root 2 times root 2. So 2 root 2 times 2 gives you 4. So basically the angular momentum in SI units turns out to be option B, which is 16. So therefore the correct answer to this question is option B, 16. The other options turn out to be incorrect. They are multiples of 4, but when it comes to calculating the velocity and the radius, it's very important that you do not take the diameter as the radius. That happens to a lot of people. So the radius here is root 2, and 2r turns out to be 2 root 2. So we used root 2, and then calculated v, which is 2 root 2. Then we calculated L, that's the angular momentum, which is 4 times 2 root 2 times root 2, which multiplies to form 16. So 16 turns out to be the right option. Now let's look at this question. At what distance from the point of equilibrium the kinetic energy equals the potential energy for a simple harmonic oscillator of amplitude A? Now here we have a simple harmonic oscillator. Its amplitude is A, and we are given that the kinetic energy equals the potential energy. Now with amplitude A, we can find out the distance traveled. The distance traveled, which is x, turns out to be amplitude times the sine factor of the multiple of natural frequency and time taken. This is the distance of a simple harmonic oscillator. And again, this is a general formula. The velocity at which this simple harmonic oscillator is oscillating can be, it can be written down as A, which is the amplitude, times omega n, which is the natural frequency, times the cos function of the multiple of omega n and t. So omega n stands for natural frequency, and it is represented as the under root of m over k, where m is the mass and k is the constant. Actually, that would be the formula for 1 by the natural frequency. The natural frequency itself is represented as k over m. So k is the time constant, m is the mass. Now that we know the value of the natural frequency, the formula for the natural frequency, the distance and velocity in terms of amplitude, we will establish that kinetic energy equals potential energy. This is given. Now using that relation, we will need to find out the distance. So how do we do that? Now since kinetic energy is equal to potential energy, we can substitute their values. Now kinetic energy in a harmonic oscillator is represented as half mv squared, where m is the mass and v stands for the velocity. However, for potential energy, since this is a harmonic oscillator, we have half times k times x squared. K is the constant of the oscillator, and x here stands for the distance or displacement. Now over here we are given that the kinetic energy is equal to the potential energy, so we will now substitute the values of v and x. So when we move on, we see that half times, now actually we don't need to consider half anymore because the halves get cancelled, so it's mv squared equals to kx squared. So therefore mass times velocity squared would be a omega n cos omega nt whole squared equals to k times, in the bracket you have a omega n sine, it's a sine omega nt. There is no extra omega n here because this is the formula for displacement, not velocity. And the whole bracket is squared. Now what do we do? When we, expand it, we get m times a squared omega n squared cos squared omega nt squared. Omega nt because, well, omega and nt are both part of the angle theta. Now on the right hand side it's k times a squared times sine squared omega nt. Now again we have a squared and a squared common, so we can cancel those out. So what are we going to do? We're going to put the trigonometric functions on one side and the constants on the other. So what we get is m over k equals to sine squared omega nt over cos squared omega nt, which is equal to tan squared omega nt. And the left hand side is m over k. Now remember, the natural frequency was represented as the under root of k over m. So the square of the natural frequency is represented as, now before we move any further, let me clarify. Omega n squared does not get cancelled in this particular equation, so therefore we write it down. So m omega n squared over k turns out to be tan square omega n times t. Moving on. Omega n is under root of k by m. So omega n squared turns out to be k over m, which means that m over k is equal to the inverse of omega n squared. So what are we going to do? We're going to write tan squared omega nt on the left hand side. On the right hand side we have omega n squared times m over k, which in this case is the inverse of omega n squared. So therefore we get tan square omega nt as 1. So what does this mean? If tan square theta is 1, then the value of tan theta would be plus 1 or minus 1, which means that the value of theta undergoes the equation n plus 1 times pi by 4, where n refers to the set of whole numbers. So that means theta's values can range from pi by 4 to 3 pi by 4 to 5 pi by 4 and so on. So those are the values of theta at which tan square omega nt equals 1. So omega nt is equal to pi by 4. So let's consider omega nt as equal to pi by 4. So if omega nt is equal to pi by 4, we will put that value in the equation for x. So since x is a sine omega nt, we will now consider the sine function for pi by 4. The sine function of pi by 4 is 1 over root 2. So therefore the value of x is a over root 2. So x here stands for the distance from the center, and a here stands for the amplitude. So therefore x here turns out to be a over under root of root 2. So therefore, under root of 2. So therefore, if you look at the question, it is clear that for this question, option B turns out to be the right option. So the process looks long and complicated. Basically, we use the formula for displacement and velocity of a simple harmonic oscillator. And since we have the condition KE equals PE, we write that condition down, and then we apply the values of distance and velocity. Along the way, we make the observation that natural frequency is under root of k over m, and using that value, we will apply that to the equation containing the trigonometric functions, and therefore, finally, we get the value of x, or the distance from the point in the equilibrium, as a over root 2. So option B turns out to be the right option. Now let's look at this question from chemistry. Acetylene is dissolved in acetone at increased pressure and is transported. This is based on which of these laws? Boyle's law, Charles' law, Henry's law, and Dalton's law. Now, we will use elimination here, and it's clear that Boyle's law and Charles' law cannot be the answers. First of all, acetylene is a gas, C2H2, and acetone is a liquid. Now, gas dissolving in a liquid is part of solutions, while Boyle's law and Charles' law are both part of the set of laws which are known as gas laws. Boyle's law dictates that pressure is inversely proportional to volume. Charles' law dictates that volume is proportional to temperature. So therefore, both of these cannot be the basis for acetylene transported at increased pressure. So option B is incorrect. Now, what about option D, Dalton's law? Dalton's law talks about partial pressure, which is an important concept when it comes to solutions. However, Dalton's law itself states that total pressure is the sum of the partial pressures of its constituents. So if you have three gases, then the total pressure is the sum of each gases of the partial pressures of each gas. So therefore, Dalton's law again does not work, because for that you need at least more than one gas. And here we have one gas and a liquid. So option D is incorrect. The right answer is option C, Henry's law. In Henry's law, we learn that the concentration of a gas dissolved in liquid turns out to be the solubility constant times the partial pressure of the gas. And this is exactly the basis on which acetylene is transported at increased pressure in acetone. So therefore, option C turns out to be the right option. Next question. 200 milliliters of 1 normal, 400 milliliters of 0.5 normal, and 400 milliliters of 0.25 normal of a solution are mixed together. We need to find the normality of the resultant solution. So 200 ml is the same thing as 0.2 liters. We consider that to be V1. 1 normal is N1. 400 ml is 0.4 L, which is V2. 0.5 normal is N2. So again, 400 ml, that's 0.4 liters, would again be V3, and 0.25 normal is N3. So we need to find the normality of the resultant solution. Now note here, we have the normality of the solutions given and the volume of the solutions given. And we also know that all three of these samples are of a single solution. There are no two different types of solutions being mixed here. So therefore, the resultant normality turns out to be N1V1 plus N2V2 plus N3V3 over V1 plus V2 plus V3. So, what are we going to do? What we're going to do is, this is the sum of the mole equivalents, and this is the sum of volume in the denominator. So therefore, we're going to multiply each of the components here. So 0.2 times 1 plus 0.4 times 0.2 plus 0.4 times 0.5 and 0.4 times 0.25. And in the denominator, we have 0.2 plus 0.4 plus 0.4. Now, if you look at the numerator, 0.2 times 1 is the same as 0.2. 0.4 times 0.5. So this is basically 4 by 10 over 5 by 10. 4 by 10 multiplied by 5 by 10. That gives you 20 by 100, which is again 0.2. And in the last segment turns out to be 0.4 times 0.25. So that is 25 over 100 multiplied by 4 over 10, which is 100 over 1000, which is 0.1. So the numerator turns out to be 0.2 plus 0.2 plus 0.1. And if you look at the denominator, it's 2 plus 4 plus 4 over 10, which is equal to 10 over 10. So that is 1. The denominator is 1. So the net normality is no fraction. It's just a decimal point from the numerator. The denominator is shown to be 1. So the net normality here turns out to be 0.2 plus 0.2 plus 0.1, which is equal to 0.5 normal. So therefore, option A turns out to be the right option. Now let's look at some questions of mathematics. If cos A plus cos B plus cos C equals 0, and sin A plus sin B plus sin C equals 0, we need to find the value of cos A minus B plus cos B minus C plus cos C minus A. So is it 1 by 2, minus 3, 3 by 2, or minus 3 by 2? So, how do we solve this question? Now, cos of A minus B is written as cos A cos B plus sin A sin B. This is a trigonometric expression. Now, this you've studied this in grade 10. So similarly, cos B minus C would become cos B cos C plus sin B sin C, and cos C minus A would become cos C cos A plus sin C sin A. So that's how we would solve this question. However, let's start off from the other end, the condition. Now in this condition, sin A plus sin B plus sin C equals 0, cos A plus cos B plus cos C equals 0. Let's write that down first. Now, what we're going to do is we are going to square both sides. Now, the square of 0 would still turn out to be 0, but on the right-hand side, you'll see something interesting. I mean, on the left-hand side, you'd see something interesting. On the left-hand side, it would turn out to be the square of the sum of 3 elements. So, if you look at the algebraic expressions, then you find out that a plus b plus c the whole square turns out to be a squared plus b squared plus c squared plus 2 times ab plus bc plus ca. So, what are we going to do? We're now going to use this algebraic expression on both of these equations. So now both of these equations would read thus. So the left-hand side, we will use the formula a plus b plus c the whole squared. So they would now become sine squared a plus sine squared b plus sine squared c plus 2 times sine a sine b plus sine b sine c plus sine c sine a. And that is equal to 0. Let's consider this to be equation number 1. And the cos equation, let's consider that to be equation 2. So cos squared a plus cos squared b plus cos squared c plus 2 times cos a cos b plus cos b cos c plus cos c cos a. And that's equal to 0. We'll consider this to be equation 2. Now, on adding 1 and 2, we know the right-hand side would still be 0. 0 added to 0 is still 0. So, what are we going to do? The left-hand side would now read sine squared a plus cos squared a plus sine squared b plus cos squared b, we're just grouping the similar terms together, plus sine squared c plus cos squared c plus 2 times, we're going to take the 2 as common, so what we get is cos A cos B plus sine A sine B plus cos B cos C plus sine B sine C plus cos C cos A plus sine C sine A. So this particular long expression on the right hand side would read 0. But it's the left hand side that's more important to us. Now, in trigonometric expressions, we learn that the sum of sine squared A and cos squared A is 1. And we're going to use that over here. So sine squared A plus cos squared A gives 1. Sine squared B plus cos squared B gives 1. Sine squared C plus cos squared C also gives 1. So now the expression would read 3 plus 2 times. Now over here we have cos A cos B plus sine A sine B, cos B cos C plus sine B sine C, cos C cos A plus sine C sine A. But if you look at our question, initially we wrote that cos of A minus B is written as cos A cos B plus sine A sine B. So we're going to use this particular trigonometric expression inside the bracket. So what have we got? In the bracket you have cos of A minus B plus cos of B minus C plus cos of C minus A. Because if you look up here, you can differentiate them into 3 different terms, and those terms can be simplified as such. The right hand side still is 0. So therefore 2 times cos of A minus B plus cos of B minus C plus cos of C minus A is equal to minus 3. So therefore the final answer, which is the value of cos of A minus B plus cos of B minus C plus cos of C minus A, that is equal to minus of 3 over 2. So minus 3 by 2 turns out to be the right answer that we are looking for. So option C, minus 3 by 2, option D, minus 3 by 2 is the right answer. C is incorrect because it's 3 by 2. B is incorrect because it's minus 3. A is incorrect because it's 1 by 2. So this is one of those questions which are asked to be proved in the examinations. So therefore, it's a good idea to learn this by heart. So if the value of cos A cos B cos the sum, if this condition is given, and then the value of cos A minus B plus cos B minus C plus cos C minus A would always be minus 3 over 2. So therefore option D, minus 3 over 2, is the right answer. Let's look at the last question for the day, which is from mathematics. Given that sine A, cos A, and tan A are in GP, the value of cot raised to 6A minus cot square A is. Now this is a question on both trigonometry and geometric progression. Now in a geometric progression we have an initial term A, we have a common ratio R. So basically A1 over A2, A2 over A1 would always be equal to R. So the ratio of the subsequent term over the preceding term is equal to R. This is the condition for GP. So we know that sine A, cos A, and tan A are in GP. So therefore, what we can say is that cos A over sine A will be equal to tan A over cos A. So we consider sin A to be A1, cos A to be A2, and tan A to be A3. So over here, this equation holds true because the common ratio is the same. Now what are we going to do? We're going to cross multiply. So over here, what we get is cos squared A on the left-hand side, and on the right-hand side, we get sin A times tan A. Now, tan A is basically sin A over cos A. So we will take the cos to the left-hand side. So what are we going to get? Cos square A times cos A gives you cos cube of A. And on the right-hand side, we have sin A times sin A, which is sin squared A. So far, so good. Now we will convert this expression in terms of cot. So for that, what we'll do is we will write cos cube A as cos square A times cos A. So we could have done that earlier. So this is how the left-hand side would look like, and the right-hand side would be sin squared A. So when we take sin squared A to the left-hand side, it would be the denominator. So what do we get? We get cos squared A times cos A over sin squared A as equal to 1. So we will take this cos A to the right-hand side. So on the left-hand side, we have cos squared A over sin squared A. Cos over sin gives you cot. So the left-hand side is cot squared A. And the right-hand side is 1 by cos A. So the inverse of the cos function is the sec function. So now that we know that cot square A is equal to sec A, we are going to square both sides. Now when we square both sides, we get cot raised to 4A on the left-hand side and sec squared A on the right-hand side. Now, why did we use the square function on both sides? Now, this is to use another trigonometric identity, which is sec squared A minus tan squared A as equal to 1. This is one of the 3 trigonometric identities. So, now that we know that sec squared A minus tan squared A equals 1, we can write our equation as cot raised to 4A on the left-hand side, and on the right-hand side, we have 1 plus tan squared A. So therefore, what we get is cot raised to 4A minus 1 is equal to tan squared A. Now, how does this equation help us? So let's consider this to be equation 1, of course. Now, the value that we need to find is cot raised to 6A minus cot squared A. So when we take cot square as common, we get cot raised to, cot squared A outside, and then in the bracket, we get cot raised to 4A minus 1, which is exactly what equation 1 is. So what we're going to do is we are going to substitute the bracket. So what we get is cot squared A times tan squared A. Now we know that cot is basically the inverse of tan. So therefore the equation now would become tan squared A over tan squared A, and tan over tan, since the numerator and the denominator are same, the value of this expression turns out to be 1. So therefore the value of cot raised to 6a minus cot squared a when sine a, cos a, and tan a are in a geometric progression is option C, 1. So 1 turns out to be the right option. The other options are incorrect because either they're numerically incorrect or they have the wrong sign. So basically what we're doing is we use the condition for GP. So let's go through the question again. We use the condition for GP, and we so first of all we used the condition for GP, and using that we made sure that the bracket for cot raised to 6a minus cot square a when it's simplified is filled as tan squared a. And finally, cot square a times tan square a would be equal to 1. So therefore, we found out that 1 is the actual value of the given expression. So that concludes this episode of AEE Training. We hope you found this episode interesting. For more of our useful and interesting content, don't forget to subscribe to Agile Rank Mate, your partner in education. If you want to get more updates about AEE or other segments from our channel, then please don't forget to hit the bell icon present below the video and set notifications to all. So until the next webisode, take care, stay alert, bye-bye for now.